Lesson 37, adding and subtracting rational expressions. It's just like adding and subtracting regular fractions. You have to have a common denominator. And in order to be a rational expression, you have a polynomial in the denominator. So finding the common denominator is probably what the lesson is mostly about. So a rational expression is a ratio of two polynomials. So for example, if I want to add x over x squared minus 9, and I want to add x plus 3 over x squared minus 9. So I want to add these two fractions together. Just like in regular fractions, you keep the denominator the same. And then you add the numerators, so this would be 2x plus 3 over x squared minus 9. And then I mentally think about, well, if I factored this, I'd have x minus 3, x plus 3, but that's not the same, so I'm not going to be able to cancel, so I would just leave it like that. Carter?
What happens when your denominators aren't the same?
That's what we're doing next. Spencer?
Is there a way you can like factor the negative 9 and 3, just divide them by 3, or is that not allowed?
No.
Okay.
We need an ambulance.
Thanks.
You know that one, you need a checkup from the neck up to cure your stinking thinking? That's what we need an ambulance for. Do not cancel unless they're full factors. So imagine there's parentheses around these, or just put parentheses. You cannot cancel. Okay?
Okay.
Yes.
Just saying, I have two things. One of the things that you said are on tape now.
I know. Second.
Second, with like two different denominators, like if you had x squared minus 9 and then like 3x plus 2, wouldn't you just like and you were adding, you would put x squared minus 9 in parentheses plus and then that, right?
No. No. When we are adding or subtracting fractions, we do not add and subtract the denominators. They have to stay the same, which means we've got to get them the same first.
Wait,
So
what if you can't get them the same?
you can find the least common denominator of two denominators. Okay. So I'm just going to give you an example of finding the least common denominator. So we have 1 over 8x minus 1 over 11x. So they both have an x in common, so we can leave the x there, but we need a common denominator that has the 8 and the 11 in it. Carter?
88.
88. So I need an 88x in the denominator. So I need to change the first fraction and the second fraction to have 88x in the denominator. So I look at the first one. I have to multiply this 8x by 11. So when I multiply that by 11, I need to multiply my numerator by 11. That way I'm multiplying the whole fraction by another fraction equal to 1, and by the identity property, it will still have the same value. It will just look differently. So 11 divided by 88x, and then this one I had to multiply by 8, so I will multiply the numerator by 8, and then we can subtract. 11 minus 8 is 3 over 88x. So to find the common denominator, once you find it, then you have to rename your fractions with the same denominator. So here's another one. 1 over 3y minus 1 over 16y. We can get a common denominator of, they both have a y, so we'll leave that in there. Now we need a 3 and 16, a multiple that both of them can go into. Spencer?
So, never mind.
Okay, never mind. Carter?
I put myself wrong.
48 is correct.
I was gonna say 32, but that didn't work.
But it didn't
So,
work. So we had to multiply 16 by 3 to get 48. So we do 1 by 3 and get 3. 3 by 16 and 1 by 16. So 16 minus 3 is 13 over 48y. Yes.
Okay, so if it was the 12 instead of the 13, could you reduce further? If it was 12 over 48y?
Yes. Then you would
1 over
have
4.
1 over 4y.
4y.
Yep. You can reduce that. Okay, instead of doing more examples, we're going to do the lesson practice to get more examples in our notebook. So this is the end of this lesson tape.